Okay. We will begin 6.4 polynomial functions part 1. After I grab my pen right here. Okay, I'll shut up now. Yeah, let's talk about polynomials. Ooh, this is what they have in the book, this big square up here. I'm going to suggest maybe we don't need to write down that entire square. Okay, it does say a polynomial of degree n in one variable x is an expression of the form. They have a sub n x to the n power plus a sub n minus 1, all the way here to a sub 0, where the coefficients represent real numbers, a sub n is not 0, and n represents a non-negative integer. All right, so here's an example of a polynomial. Why don't we just jump to that? 3x to the 5th plus 2x to the 4th minus 5x to the 3rd plus x squared plus 1. These are your coefficients. Yeah, and yeah, that's that. Poly means many. Probably better write that down in your notes. Poly means many. The nomial part actually comes from this word namos, which means names or terms. So we think of it as having many terms. This is a term, this is a term, this is a term, this is a term, this is a term. One variable means we're only talking about x, or we only have y's. We don't have x's and y's and a's and b's and z's. Degree, you're looking at your highest exponent. Please recall, you have to add your exponents of a term to get the degree of the term. And then it's the highest exponent term, I should say, with that. It's a term that has the highest degree, I guess. So the degree of this polynomial, or this term, is 3. The degree of this one is 1. The degree of this one is 0. So which one wins? 3. So the degree of the polynomial is 3. Let's look at this one. This has a degree of 5. This has a degree of 4. This has a degree of 3. This has a degree of 2. This has a degree of 0. Which one wins for the whole polynomial? 5. Okay, little tidbits. Let's jump ahead. Example 1, state the degree and the leading coefficient of 7z cubed minus 4z squared plus z. If it is not a polynomial in one variable, explain why. Oh, why am I writing? Explain why. I'm going to say why not. 7z to the 3rd minus 4z to the 2nd plus z. 7 is your leading coefficient. Okay, so that's our leading coefficient. And what do we have to do? Oh, the degree of the polynomial. We have a 3, we have a 2, we have a 1. Which one wins? The degree is 3. It is a polynomial in one variable. The only variable we have are z's. Example 2, 6a cubed minus 4a squared plus ab squared. What's the degree? Well, this has a degree of 3. This has a degree of 2. This has a degree... Okay, I wrote that little 1 in there so we don't forget. This has a degree of 3. So what's the overall degree of the polynomial? 3. Because 3 wins. It's kind of a tie, but they tie it the same. So there you go. The leading coefficient is 6. It is not a polynomial in one variable. Why? Because we have a and b. We have a's here and a's here, but we have a and b somewhere else. Example 3, 3x to the 3rd plus 2x squared minus 3. The leading coefficient is 3. The degree of this term is 3. The degree here is 2, and the degree here is 0. And what's the overall degree of the polynomial? 3. It is a polynomial in one variable because we only have x's to refer to. Here we go. 3x squared. Now you got the hang of it. You're like, oh, another one? Yes, for good measure. All right, 3x squared plus 2xy minus 5. The degree. Well, this has a degree of 2. This has a degree of 2. This has a degree of 0. What's the overall degree? 2. The leading coefficient? 3. It is not a polynomial in one variable because we have both x's and y's in our problem. Okay, here we go. Here's some simple examples. When you see this, we had this earlier this year, p and then parentheses. This means p of -2. That means you have the function p. Function means it passes the vertical line test. It also passes the birthday test. Either way, this is your function. You see p of negative 2. Let's not make this harder than it is. You're going to write p of negative 2 equals. Instead of writing x cubed, you're going to write negative 2 cubed. Here's where the math comes in. Be smart. Write your parentheses if you're going to type this into your calculator. And then we have negative 2 to the 5th power. All right. Negative 2 to the 3rd power is the same as negative 2 times negative 2 times negative 2, which is positive, no, I'm sorry, that's negative 8. 2 to the 5th power is 2 times 2 times 2 times 2 times 2. Let's see, that's 4, times 2 is 8, times 2 is 16, times 2 is 32. So you have minus, I'm going to put this in parentheses, negative 32. So this part is the negative 32. This minus goes with this minus. Look at this. We could be making mistakes all over the place, but no, we're going to take our time and make sure that we don't. When we have minus and negative, that's the same as plus. And so my answer seems to be a 24. So how do I write this? I would like you to write p of negative 2 equals 24. Example 6, find q of 3. Well, here's your function q. I'm going to rewrite it. I'm going to write negative 7. Instead of writing x, I'm going to write 3 squared plus 5 times 3 plus 9. Basically what I'm doing here, see how 3 is written in place of the x? So every time I see an x here, I get to write a 3. And then I just figure it out. So q of x is equal to this. So now I have, and this is where I have to be careful. This math happens first. So I have 9 times 7, which is negative 63, plus 15, plus 9. All right, let's keep going. We have negative 63 plus 24. 24 to 64 is about 40 away, so we're 39. Does that make any sense? 50, 63 looks good to me. So I have to write f of, oh, it's not an f. Goodness gracious. It's a q. Uh-oh, that was going to make me nervous for a second there. It's a q of 3 equals negative 39. All right, then they get more complicated. Okay, you're like, that's not so bad. Well, the only thing is now we got a function. Instead of writing x in my function, oh, there's the only x I have. I'm going to write 3a. So now I'm going to write m of 3a is equal to 2 times 3a squared minus 4. Oh, but wait. 3a squared happens first. So I really have 2 times 9a squared. See how we have to use our techniques from last, or this is actually earlier this chapter. 3 gets squared, a gets squared. And then I still have minus 4. 2 times 9a squared is 18a squared. And then I have minus 4. There's nothing else I can do with that to simplify. So I write m of 3a equals 18a squared minus 4. Yeah, you're not going to have a number on this one. You have a variable as a problem. Example 8, find r of x plus 2. All right, here's my r of x. There's my function. So I'm going to write x plus 2 every time I see an x. So I write the 2, put parentheses, x plus 2 squared. Then I have minus 5x, but I don't write x. What do I write instead? I write x plus 2. And then I have plus 1 at the end. Now I just have to do the math. Okay? Write this out twice in FOIL. I should probably show you the steps, but it's going to be x squared plus 4x plus 4. If you're confused on that, write this out twice and FOIL. Minus 5x minus 10 plus 1. I got that negative 5x minus 10 from that. I'm going to keep going here. 2x squared plus 8x plus 8. I'm just going to copy this part down. All right, now I'm going to combine like terms. Okay, and how did I do this? I took 2 times everything. So I'll kind of explain a little after the fact. Okay, 2x squared. All right, I got an 8x minus 5x, which is 3x. I've got 8 minus 10, which is negative 2. Negative 2 plus 1 is negative 1. And that is what r of x plus 2 equals. All right, now let's look at this one. Notice how we worked our way up. This is kind of the only book example type they gave. Scary, huh? All right, so we have find g of this. So in other words, my function g, I'm going to put 2x plus 1 in place. And then I see 2 times the function g of x. Now, g of b equals b squared plus 3. Okay, so I am going to put 2x plus 1 in for every one of these. So g of 2x plus 1 is going to be equal to 2x plus 1 squared plus 3. Okay, and now I'm going to write this out separately. We'll subtract them later. Okay, I'm going to put down 2 g of x's. I don't quite understand why they have a b there. It feels to me a little, I guess it's okay. Here we go. So 2 g of x's means I take 2 times this function b squared plus 3. Okay, which is the same as 2b squared plus 6. So now they want us to take this function here, which is this one right here, right? Because this is the pink. And then this is the green. Oops, I meant to highlight this. Taking away 2 of these, because this is the green over here. I don't remember what color I have that on. Maybe this one. Okay. All right. Oh, and the green, of course. All right, you gotta pay closer attention. All right, so here I go. I'm taking this 2x squared plus, I'm going to write out 2x plus 1 times 2x plus 1. Why am I doing that? Because it says squared. Why do I have to write it out twice? Because that's what we do. 4x squared plus 2x plus 2x plus 1. How did I do that? That's F-O-I-L. I foiled. All right, and now I'm going to combine like terms. 4x squared plus 4x plus 1. So really this function right here, if I go through here and over this way, is actually 4x squared plus 4x plus 1, but then I have a plus 3, this plus 3. 4x squared plus 4x plus 4 is what that is. Now, I'm going to take this as my pink function, right? Wow, that's a lot, you guys, isn't it? Pink function. And I'm going to still minus the green function. I haven't even done what I set out to do yet. So here I go. 4x squared plus 4x plus 4. And then I minus, and here's the kicker, I got to minus the entire quantity to b. I don't like it. How come I have b's in one? That, oh, I have to put x in this place. My bad. Because they say put x in place of. So this should be an x as well. So I have 2x squared plus 6. All right, now I'm going to, remember how we did this earlier this chapter? I think it's one of those things we're still kind of struggling with a little bit. Plus, minus, minus. So my suggestion, just to switch the signs, otherwise multiply by -1. 4x squared minus, my bad, again, 4x squared minus 2x squared is 2x squared. I don't have anything to join the 4x with, and then in the end I have a plus 4 and a minus 6, so that's minus 2. Holy cow, that's our answer right there. Example 10. All right, here's my function. Kind of a very, very similar type of problem. B, here's the function right here. They want me to find b of 2x minus 1 minus 3 of bx. Okay, so I'm taking 3 times the entire function. Then I'm putting x in place of m. So here I go. B of 2x minus 1 means every time over here I see an m, I'm going to write 2x minus 1 in its place. So I have 2 times 2x minus 1 squared plus m, but instead of writing m, I'm going to write 2x minus 1. Don't really need the parentheses. And then I still have minus 1 at the end of it. 3 times b of x. That means I take 3 times all of this, but I'm going to change the m value to x because they tell me to do so. Well, what does this end up being? 6x squared plus 3x minus 3. Now what do I have to do up here? I have to do a lot of math. I have to take 2 times this, but what's this? I write it out twice in FOIL. So here I go. I'm going to do a little bit more here with this. 2x minus 1 times 2x minus 1. I don't need to write squared. I am writing it. I am doing it. Minus 2x minus 2x. How did I get that? I FOILed. So now I have 4x squared minus 4x plus 1. I can't forget about this little 2. The 2 goes in front of that whole thing, and now I'm going to multiply 8x squared minus 8x plus 2. Then I'm going to add this in, so let me write that out, plus 2x minus 1, and that means minus 1. So now I have 8x squared, these combine together, negative 6x, this, and this, guess what they combine to become? Nothing. 2 minus 2 is 0. So really, this piece right here, this is all around here, this is your final answer for that. Okay? Basically, this green, and now I'm going to take away, I'm calling it red now, this part, which is the same as this. So let me rewrite. The green, 8x squared minus 6x, and then minus, because that's what they tell me to do right here, minus 6x squared plus 3x minus 3. Whew. Now, what do I suggest you do? I suggest you switch the signs. So minus, switch, 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 switch. It's basically the same as multiplying everything here by negative 1. Combine like terms, 8x squared minus 6x squared is 2x squared. Negative 6x and negative 3x is negative 9x. And I still have a positive 3. And that should be the answer there. Okay, so that's a hot diggity dog kind of problem. That one in number 9. Which is wonderful that we are going to be finished with this little section. Woo! Or that part of the lesson.